So, like I was saying, today is all about learning the unit circle. Now, I'm not just going to give you the values of the unit circle and move on. I want you to truly understand the unit circle. I want you to understand where these values are coming from. So, what we're actually going to be doing is we're going to be creating the unit circle. Now, does this mean you have to memorize how to create the unit circle? No. No, you do not. But it is very, very good for you to know where exactly these values come from. Now, one of the great things about the unit circle is that it allows you to know values on right triangles and values on the unit circle without using your calculator. That's what makes it so great. They love, love, love to put this type of question on SAT non-calculator portions. Love it. Um, because you technically don't need to know or you don't have to use a calculator to find missing values. You just have to know about the unit circle. All right, so like I said, we're creating a unit circle. Now, in order to create the unit circle, we do have to remember about special right triangles. We did learn about this in geometry. I know you don't remember geometry, but I just have to say we did learn it before in geometry. Um, so we did learn it, and I believe in Unit 2, we skipped over special right triangles. It's because we're going over them right now. So I said we'll learn them later. We're learning them right now. What a special right triangle is either a 30, 60, 90 triangle or a 45, 45, 90 triangle. Now these values are referring to the angle measures. Now what makes them so special is no matter what the values are on the side lengths of the triangle, the side lengths will always have the ratio of x square root 3 to 2x. Now what this means is the side across from the 30 will always be x. The side across from the 60 will always be x square root 3. And the side across from the 90 will always be your 2x. No matter what your values are, they will always hold this exact ratio. So for instance, let's try it. If our side across from the 30 was 2, what would the side across from the 60 be? Yes, exactly. You now know that x is 2 in this example. So wherever I see an x, I can substitute 2. So the side across from the 60 would be 2 square root 3. What would the side across from the 90 be? Yes, 2 times 2, which is 4. So this is just an example. This is how you can know side lengths on a triangle when you're only given one side without using your calculator. Now on a 45, 45, 90 triangle, it has it, it is special in that it has the side length ratio, but they are a different ratio. Instead of it being x squared 3 to x, it is the side across from the 45 is x, the side across from the other 45 is also x, and the side across from the 90 is x square root 2. So again, the 45 side across from 45 will always be x. The side across from the other 40, whoops, stop it. The side across from the other 45 is also x. And the side across from the 90 is x root 2. Okay, so let's try to solve for one of these just really quick. Really, really quick. Let's do the second one here. Now, it has an x already on this triangle, which is fine. And actually, the side across from the 45 we know is already x. So I can keep that variable x. And this angle up here has to be a 45-degree angle. Because I know that a triangle always adds up to 180. So when 80 minus 90 is 90, minus 45 only leaves us with 45. All right, so the first thing I do is label my triangle based on the side length ratio. So the side across from 45 is x, the side across from the other 45 is x, and the side across from the 90 is always x square root 2. Now, do you immediately know what your x value is here? No, no. You have to solve for x. You know that the side they give you is the side across from the 90, that 6 value. So we know that this side length is 6. We also know that the side across from the 90 is always x square root 2. So these two side lengths are equal. So to solve for x, we need to divide by square root 2. Now I do have a what? Can I just now leave it as 6 over square root 2? No, right? What's wrong with it? Yeah, you can't have a square root in the denominator. We need to do what is called rationalizing the denominator. We do this by multiplying by the square root of 2 over the square root of 2. So x now becomes 6 times square root of 2. They just are written right next to each other. They can't be combined. And square root of 2 times square root of 2 is 2. Can this be simplified further? Yeah. Right. You know that 6 and 2 can be simplified. 6 divided by 2 is just 3. So here, my x is actually 3 square root 2. And the side that they wanted was the side across from the 45, which we now know is just x, which is 3 square root 2. And I'm done. I'll do one more. I want to do a 30, 60, 91. Which one do I want to do? Should I do the easier one? Yeah, we just did a hard one. So this is a hard one just because you have to rationalize the denominator. So let's go ahead and do an easier one to give us a breather. This one right here. Again, the first thing you're going to do is you're going to label your triangle based on the side length ratio. Now I know this is a 30, 60, 90 because 180 minus 90 is 90, minus 60 is 30. This angle has to be a 30-degree angle. And I'm now going to label my side lengths. So the side across from the 30 is x. Okay, that's already there. The side across from the 60 is always x square root 3. And the side across from the 90 is always my 2x. Do I immediately know what x is? I mean, kind of, just because it's super simple math here. But, like, does it immediately tell you x? No, right? No. We have to solve for x. 6 divided by 2 is 3. So here, x is just 3, meaning the side that they wanted us to find across from the 30 is just 3. I hope that this is coming back to you just a little bit. I hope that you're not totally blown away by this because we did spend like 2 days in geometry on it. If you're like me, which from year to year, math totally goes out of your brain. Like I have to relearn every year. But if you're like me and you literally cannot remember 2 years ago, I did teach geometry. So on my channel, I do have a whole entire video going over special right triangles. So later on in the year, if we're asking you to not use a calculator, if you magically go back to school and you can't use the calculator, you'll have to remember how to use special right triangles. And you're like, well, I can't right now. You can go and watch my channel video on special right triangles. And I go much slower. I go much, much slower through it. Okay? All right. So now we're actually going to be creating a unit circle. The best part of today. I love this. I love, love, love it. So notice that we have three quarter circles. And what these are representing actually is the first quadrant on the unit circle. So we know that if we're looking at X and Y plane like this is our first quadrant, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So what we're looking at now is quadrant 1 of our unit circle. Now, does anyone know why the unit circle is called the unit circle? If you like went into Best Buy and you're like, oh, do you have this in stock to a worker? And they're like, oh yeah, we have a unit in the back. What does that mean? Hmm, that is what a unit circle is. Yes, the unit circle is used to solve many, many things, but specifically the word unit. If I say I have a unit, what does that mean? Hmm, technically, no. If you, okay, I guess I'll just tell you. You're not like, I think you're overthinking it. A unit is just a single one unit. Yeah, one of an item. If I say, oh, I have a unit in the back, it means you have one of that item. So the unit circle is called the unit circle because the radius is one, always. The radius is one. That's why it's called the unit circle, because the radius is one unit. One. Okay. So what we're going to be doing is we're going to be creating three triangles inside of the quadrant number one. The first triangle we're going to create is on this first dotted line. Now I'm drawing a solid line on that first dotted line, and then what I'm going to do is that dotted line creates a point on the edge of the unit circle. From that point, I'm just going to drop a line straight down to the x-axis. Because I dropped a line straight down, what that means is this angle right here is a 90-degree angle. Does anyone want to take a guess what type of triangle this is maybe? Keeping in mind what we just did. Yeah, it's a 30, 60, 90 triangle. Now, never, ever, ever in math do I want you to just guess at what type of triangle or what type of angle you have. But I am telling you that this is a 30-degree angle here, and this is a 60-degree angle. This is because this dotted line that we drew our hypotenuse on is a third of the way through our quadrant. So a third of the way, a third of 90 degrees is 30. What other value can I put on this triangle? There's one more that I can just immediately write down. Keeping in mind the name of this thing. The name of the circle. This circle is the unit circle. So unit circle has a blank of blank, has a blank of blank. We are with it today. Say that again, Laura. Okay, so where can we put a 1 on this triangle then? Length of, oh, well, so we know that this is 1, right? But that's not on our right triangle. We're trying to put one more value on the right triangle. What else, what other line do we know is 1? Oh boy, guys. The hypotenuse. The hypotenuse is 1. The hypotenuse is 1. Isn't that still the radius of the circle? Isn't this the radius of the circle? Isn't this the radius of the circle? Those are all 1. They're all 1. Okay. I know it's Friday and we don't want to think on a Friday. It's fine. No big deal. Okay. So now, because I have 1 of the side lengths, I can know all of the side lengths because this is a 30, 60, 90. I can know them all without even using a calculator. But I do need to solve for them. Now we know this is a 30, 60, 90. The side of the 90-degree angle in our side length ratios is always what on a 30, 60, 90? Oh my God. I am not gonna, right, QX. Yeah, the side across from the 90 is always 2x. So here, our side length across from the 90 is 1, and it has to be equal to 2x. So in order to solve for x, I divide by 2. So here, x is a half. Now, where or what are the other side lengths on this triangle? I need to create possible. Yeah, so the side length across from the 30 is, now we know it's 1/2, right? Because the side across from the 30 is just x. And the side across from the 60 is x square root 3. So I think, Matthew, you're trying to answer it. 1/2 times square root 3. The square root 3 just goes in the numerator, making it square root 3 over 2. Okay, so now let's do our next triangle. Actually, no, let's pause because I want to explain exactly why this is so important. Looking at this right triangle and the values that we just found, these values can tell us something extremely important on this unit circle. They can tell us this coordinate point of the point that this angle creates, knowing that this center point is actually located at 0, 0. So knowing that center point is at 0, 0, and thinking about the values we just found, what is this coordinate point? So look and think about first you're finding the x value. What is the x value of that point? Not 1. Mm-mm. Right. To get to the x value of this point, it's just the bottom length of this right triangle, right? That's the distance on the x-axis for that point. Square root of 3 over 2. What is the y value for this point? 1/2. 1/2. Also, also, we can now know, because we know this coordinate point, we can now immediately know the sine and cosine value of that 30-degree angle. If I'm thinking about sine first, we know sine is O over H. So what is sine of 30? Which is just 1/2. 1/2, our opposite side is 1/2. Our hypotenuse is 1. So 1/2 over 1 means that the sine of 30 is 1/2. Look, that's our x value. What about the cosine of 30? Cosine is A over H. So what would the cosine of 30 be here? What would the cosine of 30 be here? A over H. I might have to re-record this in a different class because the pauses are just too much. Yes, right. A, the adjacent side is square root of 3 over 2. The hypotenuse is 1. So square root of 3 over 2 over 1 is just square root of 3 over 2, which is our, oh my gosh, x value. So knowing this coordinate point will immediately tell you the cosine and the sine of that angle. This is true for every single coordinate point on the unit circle. You can immediately know the cosine and sine of that angle just by knowing the coordinate point. This is why the unit circle is so great, because you can immediately know values without having to use a calculator. Okay. So now let's do the next triangle. Let's do this one right here. Anyone want to take a guess at what this triangle is? Yes, this, because it's halfway through our unit circle, half of 90 is 45. So this angle here is 45. This angle down here is 90, and that means that this angle here has to be equal to 45. Now, what is the last value that I can immediately put on this triangle? 1. Yes, 1 on the hypotenuse, right? The hypotenuse is the radius, and we know this is the unit circle. The radius is always 1. So again, we have to solve for these side lengths. On a 45, 45, 90, the side across from the 90 is always what? Yes, x square root 2. So we do need to solve for x here by dividing by square root of 2. Now, can we just say that x is equal to 1 over square root 2? No, right? We need to rationalize that denominator by multiplying by the square root of 2 over the square root of 2. So this leaves us with x being square root of 2 over 2. And this is the side length across from both of the 45. So knowing that, What is our coordinate point for the 45-degree angle? What is our coordinate point for the 45-degree angle? What is the x value first? Yes. Square root of 2 over 2, comma, square root of 2 over 2. Now, this means, what is the cosine of 45? What's the cosine? Yes, cosine of 45 is square root of 2 over 2. And that then means that the sine of 45 is also square root of 2 over 2. So yet again, the coordinate point told us immediately the cosine and sine of that angle. And lastly, this is the easiest one because we've technically already actually solved for this triangle. Because it's actually the exact same triangle as our first triangle, it's just the values are in different spots. So this again is a 30, 60, 90, but the difference is the 60-degree angle is now the reference angle at the origin. So this is our 60-degree angle and this is our 30-degree angle. And we still know that the side across from the 90 is 1. Still 1. Now we are, like I said, we already solved for this triangle. So what side length do I put on the side across from the 30? Exactly, yes. The side across from the 30 on the first triangle was 1/2. So same thing here. The side across from the 30 is 1/2. What about the side across from the 60? Yes. And this now means, what is our coordinate point for a 60-degree angle on the circle? What's our x value? Ooh, yes, exactly. So what's our y value? Yes. All right. So that means that the sine of 60 is square root 3 over 2, and the cosine of 60 is 1/2. It's always going to be that the cosine is the x value and the sine is the y value. Always, always. Okay. So now we're going to take these values that we just solved for, and we are going to start. Ooh, what the heck is happening here? And we're going to start solving for our unit circle. We're going to finish creating it. So all I'm going to do is I'm going to take the values I just found on those 3 triangles, and I'm going to fill in the values here in the first quadrant. So in quadrant 1, that 30-degree angle, the coordinate point was square root 3 over 2, comma 1/2. The 45-degree angle was square root of 2 over 2, comma square root of 2 over 2. And the 60-degree angle was 1/2, comma square root 3 over 2. That's what we just spent all that time solving for, was those 3 points. Now, knowing these 3 points, you can then know all of the rest of the points of the unit. These are the main three. And as long as you know them, you can know everything else. Now, does anyone know what this 0-degree angle point, what the coordinate point there would be at this 0-degree angle point? You're close, Peyton. You're so super close. Instead of it being 180, you know that this is the unit circle. Yes, Peyton. This right here from 0, 0 to this point is a radius of 1. So the x value here is 1, and the y value is 0. 1, 0. What then is the 90-degree angle? What is the coordinate point of the 90-degree angle? Yes, our x value is 0, and our y value is up a radius of 1. Now, here comes like the most mind-blowing part. How can you find this coordinate point? What? It's fine. Ah, you mean this one? And doing what with it? Mm, so think instead about what the first easiest is what's the y value, the height of that point. Did the height change between those 2 points that I have circled? No. So what was the height of this point? What was the y value of this point? So that means that this is square root of 3 over 2. And then this new point is the mirror image of our 60-degree angle. So the x value was a positive 1/2. It's being mirrored and it now becomes, no. So I go in the positive direction 1/2. I'm now going in the negative direction 1/2. So this is negative 1/2. And you do that exact same process for all of the points in quadrant 2. Does someone want to take a guess, take a stab at what the 135-degree angle is going to be? Oh, exactly. It's negative square root of 2 over 2, and you keep the same y value of this point, square root of 2 over 2. What about the 150-degree angle? What's that going to be? Exactly. Yes, yes, yes. So if you think of this quadrant 1 as having a positive value and a positive value, quadrant 2 is going to have a negative and a positive. What about quadrant 3? What do you think quadrant 3 is going to have? Right, both negatives. Both negatives. So it would be, what color do we want to do? I don't know. What haven't we done? Pink. No, that's pink. Okay. It would be a negative, comma, negative. Now, I did skip over it. What is the 180-degree angle? Yes, exactly. Negative 1, comma 0, right? We will, in the negative x direction, 1. So, and then the coordinate points for the third quadrant is just taking our same values but making both of them negative. So this angle right here, this 210-degree angle, is going to be negative square root 3 over 2, negative 1/2. I'm just looking at this angle right here because it's the mirror image of that angle, and I'm making both of them negative. What about the 225? What's that going to be, you think? Exactly. Both negative. And lastly, what is the third in that quadrant? The 240. Exactly. Yes. Good. Wonderful. And then what is the 270-degree angle? Yep, the x-axis is 0. And we go down on the y-axis 1, so it's negative 1. And then last but not least is our fourth quadrant. What pattern is this fourth quadrant going to have? The x value is going to be, and the y value is going to be exactly. So I'm just, for time's sake, going to finish filling these in. Our x value is positive, so our x value here is positive 1/2, and our y value remains negative, so it's still negative square root 3 over 2. Our 315-degree angle is now going to be a positive, whoops, not square root 3, square root 2 over 2, comma, negative square root 2 over 2. And our 330-degree angle is going to be a positive square root 3 over 2 with a negative 1/2. And boom, I now know 12 different sine and cosine values of 12 different angles. Actually, 16 different angles, right? Can't forget about these ones on the 90 degrees. Now, there is also a pattern to memorizing the initial quadrant, this quadrant number 1. Does anyone want to take a guess at what pattern you see there on the values of quadrant? What do they all have? Yes, they're all over 2. What else? What else? They're all positive in the first quadrant. Yeah. What do almost all of them look like they have in the numerator? Square root. Actually, every single one has the numerator square rooted. But what is the square root of 1? 1. So you can think they all have the numerator square rooted, all of them. But the square root of 1 is 1, so it cancels out. Also, look, the pattern is 3. Yeah, they're all over 2. They're all having the numerator square rooted. And it goes 3, 2, 1, 3, 2, 1. Done. So I can immediately, from memory, immediately know, let me find a blank spot. Immediately know the first quadrant because I know they're all over 2. So I put them all over 2. They're all square rooted in the numerator. And it goes 3, 2, 1, 3, 2, 1. But the square root of 1 is just the 1. Done. Boom. I don't know if I just don't remember learning this pattern, or my teacher never showed me this pattern, or I was super bad at remembering patterns. I don't know. But I totally, every single time I went to do the unit circle, solved using special right triangles to find these values. I didn't just memorize this pattern. I did way more work than I needed to. If you memorize this pattern, it is going to save you so much work in the future. So much work. All right. Also, mm, we're just going to finish up these little definitions here. We know that on a unit circle, the sign is always the what value in the coordinate point. Sign is always the, what did we say? In our special right triangles we solve for. Sign was always the, look up here. Yes, sine was always the y value. So sine of theta is always going to be equal to the y. What was the cosine always? Yes. Now, if you did your math accelerator, you may have already learned this. What is the relationship between sine, cosine, and tangent? What is tangent always equal to? Yes, it's always sine over cosine. That's what tangent is always equal to, is sine over cosine. So to find tangent, you just do y over x. And then the other three are super easy. They're just the reciprocals of their original functions. And then you can also know which trig values are positive in certain quadrants by memorizing the acronym. Whoa, not that. All students take calculus. What this means is all trig functions are positive in quadrant 1. Sine and its reciprocal cosecant are positive in quadrant 2. And cosine, nope, T stands for tangent. And in quadrant 3, tangent and its reciprocal cotangent are positive in quadrant 3. And quadrant 4, calculus starts with a C, so cosine and its reciprocal secant are positive in quadrant. That's basically all that you need to know in order to do anything on the unit circle, because all of the questions, whoa, all of the questions are going to ask is just you looking for that angle on the unit circle and knowing the how to find the trig function at that. So cosine is always the x value. So you go up to your unit circle, you find 90 degrees, and you're looking for the x value, which is 0. Then you go back down and you say cosine of 90 is 0. Done. I will record myself doing some of these harder problems, but as long as you're a good logical thinker, you really don't need to watch it. You can think your way through it. But if you're not a really good logical thinker, you can watch my example video that I'll create. But if there's no question, that's it for today.